So my previous EMP video is now the most viewed on my channel, so I thought let's make another one, this time bigger and more powerful. The main component for this build is a 10,000 volt neon sign transformer, which can do this. The first step is to replace this pull switch with a red momentary button. To do so, we need to take apart the casing. So as you can see, here is the pull switch, and this is what we need to remove. So right now I'm trying to free the two wires that connect to the switch. Now we need to solder these wires to the new momentary button. But first we need to extend each wire so the button can fit outside the box. I'm also using some heat shrink tubing to make sure the transformer doesn't accidentally turn on. This is what it looks like when we're done, and now we can thread them back through the initial hole. This is what it looks like now, and the button will be connected towards the end of the project as it is the last piece. For the housing of the EMP, we'll use this dolphin torch. This is a design diagram for the EMP, and it's basically the same as the previous one. In the middle we have our neon transformer, and this is encased in our torch housing. It's powered by our DC output wire, and this creates a high voltage which leads to the spark gap. In my previous EMP video I had a lot of people ask what the spark gap was for and what it does. Well, basically when the spark occurs it discharges the buildup of charge, resulting in a change of magnitude that leads to the electromagnetic field. So I hope this cleared that up. This then leads to the magnetic copper wire coil, which outputs the electromagnetic field, and then it links back into the transformer. And this is all controlled by the switch, which were the two wires we were wiring up earlier. Now we need to get the torch casing ready for the transformer. So I ran into a problem early on that the transformer was a bit too big for the casing, so my solution was to cut a hole in the back of the plastic. This allows us to fit the transformer properly and also have the plug coming out of the back. This is what it looks like when it's been cut, and now all the wires and the transformer should fit properly. For the coil we'll be using this 2mm thick enamel coated copper wire, and for the spark gap the prongs will be these two nails. So one high voltage wire will be connected to a nail and the other will be connected to the copper wire. Both nails are hot glued onto the transformer box so they stay secure and don't move around. Our other nail will be placed at an appropriate distance for the spark gap. Before attaching the other nail to the copper wire, I sanded off some of the enamel coating on the end so that it will conduct properly. Next, I drilled 2 holes in the acrylic face to allow both ends of the coil to stick through and connect inside. Once this end of the copper wire is through the hole, we can connect it to the nail. Now that the wire has been connected, we can create the coil by wrapping the wire outside the box in a circular shape. Once I cleaned it up and added zip ties, this is what it looks like. I also hot glued the coil to the face, and if we turn it around you can see that both wires are sticking through the holes into the inside. I also ran into another problem, which is that the cap must twist on. This makes it impossible for me to attach the wires and the nail to the top of the transformer. To get around this problem, I decided to sand off the grooves so that the cap could just be pushed on. Now the cap can be pushed on straight and everything should work now. However, I will be adding some hot glue later to make sure it's secure. Now it's time to attach the other high voltage wire to the copper and the nail on the transformer. So this is what it looks like when both nails have been attached to their wires, and now the spark gap is complete. Next we need to replace the button with our red momentary switch. The 2 wires we were working on earlier will now come up through the handle and out of the hole at the top. Now that I've got the wires through, we need to attach it to the switch. But first I'll run some hot glue around the neck to attach the cap. Once the button's in place, the EMP is finished, and this is what it looks like. When the button is pressed, a spark gap will occur, sending tens of thousands of volts through the copper coil, creating an electromagnetic pulse, destroying small to medium sized electronics from about a meter's range. So let's go test it out. Before the video ends, guys, I just want to say thanks for watching, and if you're new, please subscribe. I will be uploading more regularly and I have some good videos coming up. If you are going to make this, please be very careful, as it can damage yours or others' electronics, as you just saw there, and I do believe it is illegal if you use it maliciously. So thanks for watching and see ya.